Hello there, this is Daniele from Toolchefs and welcome to this new video for the Stadium series. So you know that whenever populating stadiums, one of the most important tasks is of course, placing the agents in that stadium. And with Atoms we provide some tools that make this workflow easier. We're going to use the Atoms agents in this video, so I'm going to import the scene JSON for that one, just because so in that way we have a bit more variety of animations and agent types. In this model here, in this scene, I have a model stadium, and I've created these meshes for placing the agents on these sections. You can of course combine them if you want to have all of them together, but keeping them separate is going to be useful when using the group copy module that we're going to see in a second. Then what you can do is you can start layout your agent straight away. So I'm going to create an agent group. You can do that using the menu of the Atoms menu, or you can go here and click on this button. And then let me show you first something that's useful to know. So as you know, you have seen in the videos previously that we always created a single layout per agent group, but you can have multiple layouts per agent group. Okay, so if I do, for instance, create a new one, we see that we get this error from Atoms saying colliding agent group IDs were found. This is because Atoms allows to have multiple layouts on an agent group, but you have to be careful that the agents that are created don't have colliding IDs. Okay, so to do that, basically you have to help Atoms a little. Let me just change the center offset a little here. You have to provide a group ID offset for basically not the first layout but the other layouts. Okay, so the group ID offset takes basically an integer, which is 10 in this case, what we have provided, and use that to offset the group ID of the agents. So if I enable draw metadata and show the group ID like this, we see that the first layout is starting to create agents from ID 0. So for instance, if I create two agents, sorry, wrong layout. If I create two agents, they're going to be 0 and 1, and the other one is starting at frame 10, at group ID 10, so 10 and 11. So in this way, you can have different, multiple layouts on the same group. The only problem with this workflow is that because you might also add overrides and stuff, you have always to be careful that you don't have colliding IDs. So if you have to, for any reason, relay out the first layout here, so add more agents, for instance, then you have a bit of an issue because you need to change the value of the grid layout here, but also change the overrides. So we have a tool for that, so you don't have to do that by hand, which is called the offset group IDs. And we also have a video explaining this workflow on our YouTube channel. So if you are interested about this, you can, watch that. We're not going to go into detail here, but what we're going to do is we're going to always use a layout per agent group, which is also the workflow that I like to use. So for this layout, I'm going to assign a mesh scatter layout like this, and I'm going to assign already a state machine. So the mesh scatter layout, what it does is basically takes as input a mesh, and then it scatters agents on that mesh. So I'm going to use this mesh here. I'm going to middle mouse drag and drop that mesh on the mesh field here. Let me deactivate the draw metadata and set the draw mode to skin. So we have some agents created here, but we see they're intersecting with the ground, and they're also facing, they're pointing towards the outside of the stadium. So to fix that easily, what you can do is you can activate the apply pelvis height offset on the mesh scatter layout. And what this does, it takes basically the distance between the pelvis and the feet in bind pose, and offsets the agents above the ground using that distance. So because of course the agent root will actually be, so the root of the skeleton of the agent will actually be placed on the point that is used for the layout, which will be on the surface. So having this offset then basically brings them up so above the ground. Okay, so then we can change the direction so that they face the inside. Okay, like this, the inside of the stadium, and then we can start playing with the scatter mode. So we can change. So at the moment it's random, which means that each agent is going to take a random point on the surface on the mesh, and just is going to be placed there. What you can use is face center, and also we're going to deactivate the mesh triangulated, which is on by default on this module, because otherwise each face is getting triangulated. So yeah, now we have one agent per face. Okay, So after this, if you want to have a bit more randomization, so you don't want to have one agent per seat like this, you can use the face center iteration, which will basically use this iteration value to place your agent. So maybe you can say I want maybe say 500 or maybe 1000. So of course, if you can't find more than 1000 faces, then it will actually stop. So we can say maybe 1000 and say 2000. So we actually have even that one field, but let's say 1000. Then at this point, you can also provide a randomized radius. So we can say I don't want the agents to be closer than between the value between 10 and let's say 500, not 50, but 500. So some agents are getting clamped, and we don't see them all. Of course, if you provide low values, you won't see any agent being removed here. Anyway, for this mesh scatter, I'm going to use the face center. Here, did I save that change? No, sorry. I need to change the state machine to the main stadium state machine, simply because here, of course, we have the state machine for the stadium. You press rewind. Now they're all using the stand state. So the animation is a bit static. They're all just using one state, one animation, because in that on this state we have just one clip. What we can do is like we can randomize some of the agents. So for example, we can use the layout tool. We can select some agent using the selection search. So let's say I want to like search and select 75% of the agents. And now we can randomize the states. So if we go back to the state machine, which is here, we can use this state, which is 2, 3, 4, and 5. Yeah, let's just use this 4. So it's basically we can randomize between 2 and 5 like this. Now we see that the agents are now having, like some of the agents, of course, the selected one have different, they're not playing the stand state. Let me clear the selection. So this is basically how you can randomize your crowd quickly. And of course, you can always go in on the right dialog and or even select agents with the layout tool and then change the state. So for instance, if you wanted to change the state of a specific agent, so I press the agent selection tool, I go here, select this guy, say I want this to be on 2, set value, I rewind. Of course, if you apply any change and you're not on the first frame, you won't see the change. Let me show you. If I'm on the first frame, I do set value. Now it has changed the animation. So we set 2. Anyway, the change is small. You don't see it very well, but you see. Anyway, it's changing animation. Cool. Okay, so now we have these agents, and they're all playing. Great. Now what we can do, so basically this is the first layout. This is the first layout that you can use. Another one is the stadium layout. So let me create a new agent group, and let me add the stadium layout and a state machine again. And we provide some default shapes, so it can be square or ellipse. But of course, it's hard to match completely the shape of a stadium with this layout. If you don't have this, I mean, you can use this approach. You can use this layout if you don't have these, you know, like the faces that I've prepared here, because it's a quick way to do it. Otherwise, you know, using the faces is actually, you know, more. I mean, you have more control. Okay. So anyway, I'm gonna hide most of the sides, so we have just this one, and it's because the stadium layout is useful, especially because you can hide sides, and then you can just use that that specific side to just one specific side to you know, populate your stadium. So let me just move my agents here so that they don't intersect the ground too much, like this, bit higher, bit lower, like this. Okay. And now I can start playing with the parameters. So first of all, the thing that we have to change is the steps. So here we have just 3. Actually, we have 1, 2, 3, 4, 5, 6, 7. So we change the step here to 7. Okay. We can change the size. So in this case would be this one, and we say I want maybe 2000, a bit more. Okay, this is okay. And now we can change the step size so that the agents here don't intersect with the ground. So the step here probably could be 120, a bit more, maybe 130. Yeah, 130 should be okay. And then we can play with the height of that step. 60 is not enough, maybe 90. No, 90 is too much. 85 maybe. Yeah, it looks better, but here it's still intersecting, so maybe 86. It's intersecting there a bit too much compared to these guys here. Maybe 86.4 or something like that. Yeah, okay, I mean, yeah, maybe 0.3, let's see. Okay, so this is a bit better. Of course, you can tweak these parameters. And I've played a lot with these values just to have this, let's say, the most, the layout that fits most this mesh. But of course, you know, you could use a night feed to use the terrain adaptation. On the state machine, you have the option for adjusting the height of the agents only on the first frame, so on agent creation. And this one actually do it all the time, and it's quite useful for the stadiums. Anyway, you know, like even if you have like a lot of agents, you know, like, and you can lay out them quickly and in a precise way, like I'm doing now, is actually, you know, you can even just use layouts if you want. And then finally, the last one is the curve layout, the last layout that we're going to use. So let me create a new agent group. Before that, let me create, select this mesh. I'm going to make it live so I can create some curves here. So let me create them here on this section here. So we're going to create a curve like this. Actually, it's not very straight, like this. And then let's create another curve here. Okay, so this layout that I'm gonna use now, it basically takes two curves as input, and it's a very quick. I mean, if you have to populate stadiums and you don't want to create these meshes for the seats, you can use this one. It's actually much quicker. So you can use curve per layout and a state machine. And then what you can do is like you can drag and drop the curves into these two fields with the middle mouse button. And as you can see here, the agents have been created already. Let's use again the apply per side offset, and let's change the direction type to normal, although you can even say custom direction and, you know, type a value here if you wanted. So with this tool, with this layout, what you can do is like you can provide a number of agents for the first and the last row. Otherwise you can use the CVs, but it's just gonna use like create agents on those CVs, which is anyway not using any randomization for the rows. So which is actually not what we want. We want to use actually some randomization number. So let's say I want 20 agents on the first row, and then I want to have 25 on the last one, which basically this one is going to take some, like it's going to interpolate in the middle rows these two values. So it's going to be, this one basically has a value between 20 and 25. And you can of course change the number of rows. So we can say 7, which is the same steps that we had here. And then also you can use some random range here. We can say maybe I want to have 5 to 10 agents more per row. So now we have those. And you can also play a little with the values here for the distribution range. So you can say maybe 0.5 and 0.9, 1 maybe. So these two values will have to be between 0 and 1. So if we say 0, bring this one. Yeah. Anyway, you can play with these so that basically the distribution is a bit better. Again, then here we have the skin. You can of course here again, like with the agents here, you could randomize the state machine, the state for the state machine with the trick that I showed you earlier, and then basically you're done, right? So this is how you can use also this layout. So these are the layouts that you can use. So then at this point, you could use, you could cache the animation out, the simulation out, and then use caches. So you could use the caches and adapt them to a high field if you don't have like the same exact height between the seats, between the steps. Otherwise, there's also another trick that I'm going to show you in a second. Okay, so now before having a look at the group copy module, which is a module that lets you clone agents between agent groups, we can have a look at how we can delete our agents. So we can enable the agent layout tool, or via the menu, or either with the shelf button. Then once that is enabled, you can select agents from your layout like this. You can press Shift to add to the selection, or Control to remove agents from the selection. Then when you're happy with your selection, you can just press this button, or press the delete button on the keyboard, and those agents got deleted. On our agent group, we have this agent filter module that has been added, and this contains a list of all the agent group IDs that have been deleted. So for instance, if I delete a few from this list, those agents will appear again. And like if you want to see the agents that you have deleted, you can always disable it and re-enable it afterwards. And then you can also check the group ID if you want. So I can enable the draw metadata, enable again those agents, sorry, the module, and disable it, so we can see the agents that have been deleted and their IDs. So for instance, 26 and 27 are those ones. Let's say I want to have them back. I just delete that those group IDs from the list, and they are back here. Okay, so another way in which you can delete agents is by using the selection search. So for instance, let's say I want to select 20% of the agents. If I select the agents now, you see we have the selection happening on all agent groups. If you want to have it just happening on this agent group, on the selected one, you have to enable this option here. So let me clear the selection, select agents, and now I can delete. Because otherwise you end up deleting agents from another agent group, which is probably not something that you want. So this is a way in which you can do it. And again, by pressing that button, we have added some more IDs here. Otherwise, you can use the agent deleter tool, which you can find either in the shelf or here in tools under and then agent deleter. Here you can select the agent groups that you want to work on. And then again, here you have like some filters, and of course even in the selection search you can use them in like combining them together. So you can either use the percentage, you can at the same time filter by agent type. So you can say I want to select 50% of my men in the scene, you can do that. And also you can filter by metadata, although this value should be, the metadata should be a boolean, integer, or double, so you cannot really filter filter by string. And also the other difference, so the difference between this tool and the selection search is that this tool deletes straight away the agents, and also you can make this basically the search in a frame range. So for instance, you can say I want to get all the agents that get closer than 100 units during this frame range, so 1 to 500 frames, and the agents deleter will actually do that for you. So it will actually iterate through the simulation and then get all the agents that are matching basically the criteria that you're providing through the UI and delete those. So this is a way, so this is the other way basically. So the agents deleter, or either you do it manually or with the selection search. So let me delete the agent filter module for now. Now what we can do is we can start playing with the group copy module. So I've created a new agent group. I'm going to assign the group copy module. This module, you can assign any number of these on the agent group, although you have to be careful because what you have to do, basically you have to provide as a first argument here the so the source agent group that you want to use, so the one that actually provides the agent that you want to clone. But also a good practice is always to provide here the parent agent group, which is usually the same agent group that you have here. And this is because whenever you say this is my agent group, you're telling Atoms this module, so this agent group has to be evaluated after this agent group here that I provided here. And this is because, of course, if you want to clone the agents coming from that agent group, then having this agent group to be evaluated afterwards is actually what you want to do. Atoms, of course, evaluates agent groups in an order, and usually the order is defined by the order in which you created your agent groups. But So in a case where you actually are cloning agents coming from an agent group that maybe you have created afterwards, then this is something that you have to do, because otherwise you will get unpredictable results. So if you start having multiple agent group copies, you have to be careful that actually, this agent group is being evaluated afterwards. So basically, just to make things always bulletproof, I always like to make an agent group and just one group copy per agent group, and then just use those. I use this workflow. Okay, so as you saw, as soon as I selected the agent group, here some agents appeared in skeleton mode. Let me actually change the mode to skin. And as you can see, so the agents are matching the position of the other agents, but their pose is not matching. And this is because basically what's happening here, because we have the randomize option on, agents have been shuffled around. But if I uncheck it, now you see that the source agents are actually matching the destination agents. Let's call them the destination agents, so the target agents. So if I press play, the animation is matching. So we have an option here for delaying the animation. So let's say if I set it to 5, so and I rewind and then I go frame by frame, we see that the agents of this agent group are actually gonna have like a 5-frame delay. And this is of course great if you want to add like some randomization, even if you provide like the randomize, if you have like those frames of delay actually makes the animation a bit different. And of course you can override these attribute per agent if you want. So this attribute is particularly useful, especially when you have small agent groups and you're cloning the agent, so the simulation from one agent group to another. And again, the agent group is pretty small. But if you have like large agent groups, this doesn't really make a big difference. Another thing about using the delay, visually it's just because of course you're copying agents and the agent group is quite big. But if you use the delay, so if the value is different than 0, one thing to know is that you want to be able to use the instancing that we have in our Atoms proxy. So on the procedural level, what we do is like when we render, is we if Atoms finds an agent that has the same pose and variation of another agent, then those agents, one of the two agents is going to be instanced. So the thing is, if you start adding delays, then this is not going to happen. Again, if you have large agent groups and maybe you're just cloning the agent, so you're just having a group copy, maybe even the instancing doesn't really make a difference. But if you start having like small agent groups and then you clone them around your scene a lot, the instancing can really improve the performances at render time. So this is just something to keep in mind in case you want to use the delay. Here you have some other options. For instance, when we say we clone the animation from one agent to another, it doesn't mean that the animation is going to stay just like that, because we can still apply, change the direction, change the foot locking and things like that. You can do that. Also here we copy metadata. So for instance, you will get the variation being copied and things like that. We have a list of excluded metadata from this process, and this is the default, but of course you could change it, but just do it if you know what you're doing. You can provide another high field in case you have a different terrain where you want to place your agents. And also we can apply a mesh which can be used as a scattering mesh. So for example, if I enable this one, now the agents will disappear because they are not, we haven't provided yet a mesh. So I'm just gonna assign this mesh up here. So that one, let me go here. So that, and now the agents are being scattered on the new mesh. What you're doing here is actually you're copying the simulation. So all the agents that have been simulated, in case you had just these two agent groups, will be just these ones. So you would actually save quite a lot of time in terms of performance, meaning that you can actually, both for performance also your own time, because performance-wise, we're just simulating once. So one agent here and then the other one is not being simulated, we're just copying the simulation. And also your time is because you can just edit the simulation here, and all the changes will be reflected on all the agent groups that are using the group copy and using this agent group as a source. So you could populate the entire stadium and just having this agent group as a source, and then you can still as soon as you change something here that change will actually affect all the agent groups having the group copy module. So you don't really need, in a sense, cache your simulation and then place the cache all around your scene. You can just use this workflow, and it's actually the performances would still be good. Okay, so now we see that we are suffering the same problem that we saw before with the mesh scatter layout. So we can apply the pelvic side offset. We can say I don't want to use a random, I want to use maybe a phase iteration, and I want to have maybe 200 iterations, something like that. You can of course randomize the radius if you want. But anyway, now basically what we have here is actually a simulation, and these agents are being copied. I mean, the simulation of these agents is being copied from, again, these agents over here. So this is a way, of course, here is let's say the direction of the agents is the same, but let's say if we want to have them in this section here, we can create a new agent group. Again, we can create a group copy module and set the parent agent group, that one, group copy, that one. The scatter mesh I think is 9, yeah, so 9 there. Apply pelvic side offset, so the agents are on top of the ground. So as we said here, we see the agents are actually having the same direction of these agents, so they are looking in this direction here, but we would like to have them pointing towards the center of the stadium. So in this case, because things are, I mean, this section is not curved, we could just maybe, you know, add a metadata and say I want to change the direction to be, so the direction is a vector, so to be, that would be -1 and 1, press enter, and now the agents are actually looking towards the center of the stadium. Otherwise, what you can do is like you can, let me remove this one, you can add a follow target. You can connect a translation with the goal, because otherwise you can, anyway, you can either type that manually, so 0 would be something, but anyway, let me use that locator. So that locator is this here. So we can use the translation of this locator. Where is it? There. So that translation, let me first, need to go back there. So translation there, and I just middle mouse drag and drop it on the goal. So the agents are still not moving because we have to enable these, disable this is animated, because this needs to happen only on the first frame. We don't care about having the agents actually following the target at each frame. It's just for a layout thingy, so it needs to happen just on the first frame. We need to increase the maximum turn angle to a big value, and now the agents are looking at that locator. Target radius, in this case, it's a good practice to set it to 0. Okay, so now the agents are looking at that, so you would be able to use these workflow, this module, in case you had like a curved section here of the stadium. And if I select the locator, select that and move it, the agents are actually, let me go a bit closer so we see that the agents are actually rotating as soon as we move the locator. So as you see that. Okay, so this is all for the group copy module, and now let's have a look at how you can use a terrain. Okay, so we saw in one of the previous videos that Atoms support different kind of high fields, and I'm referring in particular to the video where we explore the seat adaptation feature. So in a case where you want to use the seat adaptation, you can use, you know, like that workflow. In a case where your clips are all working fine with the current model that you have, you can use a different kind of high fields. So let me hide this agent group. Actually, you saw that as soon as I've hidden that agent group, all the agent groups that were using that agent group in the group copy module, they got hidden as well, meaning that actually their agents are not getting created anymore. This is because when you hide an agent group, that's not getting evaluated anymore. So these two agent groups down, like the one that was here and the other one was here, cannot access the source agents anymore, so they can't create new agents. In fact, we saw this message here saying an agent type found. To create a new agent is because no agent type was found for a source agent. from the original agent group. So I'm gonna hide these two as well so they don't trigger that warning. And now I'm gonna create a new agent group, and I'm gonna use a grid layout module. In this case, I'm gonna attach also state machine, and I'm going to say maybe I want a grid of 5 by 5. The grid is down here, so let me just move it like that, change the direction. And of course you can also use this workflow in the case of the stadium layout, where you remember before we tweaked the parameters quite a bit before we could get like to a good result for like having our feet on top of the ground. Anyway, but with grid layout you actually get the point like a bit like in an easier way, because a bit more evident the result. So let me change the display type to skin, and then let me apply an I-field. So let me go in the stadium. I've prepared this mesh here. It's basically this mesh here. I'm gonna register it with the I-field manager. So you need to open the I-field manager, then click add, provide a name, press plus after having selected the mesh. This actually adds the mesh to the list. You can click OK. Now the I-field is registered. If you edit the I-field, so you move it in the scene, or maybe you edit the geometry by moving a vertex or a face, or more than one vertex or more than one face, always remember to click on it and then reload it from the I-field manager, because otherwise Atoms will always use the previous version of the I-field where your edits happened. Okay, so let me show again the seed section, sorry, and then let me go here and set the I-field in the field. Yeah, so let me rewind. Now they are there, and let me quickly move the agents a bit. This, so that was okay. So this is there. Okay, great. Here, of course, we need to tweak a little the distancing between the different rows. So maybe we can say 130 instead of 150. Okay. Okay, it looks a bit better. Maybe we can say 131 something. Maybe 132, let's say. Just to have a bit more spacing there. Great. So one thing that also you might want to enable straight away is the adjust height on agent creation only option, and this will only adapt the agents on the first frame of the simulation, not throughout the entire simulation, so the sim will be faster. Then basically that's it. So this is how you can use the terrain adaptation with the height field straight away. Let's have a look at the height field. So this is the seed section. You see here we have the steps, but on the height field, you see here we don't have any step. You see, it's like I used the same geometry and removed the step, the seed mesh, basically the one that was supposed to have the seeds for the agents. And this is because we don't have any seed adaptation here and we haven't set it up. So in that case, actually, sorry, the seed adaptation is set up by default on the Atoms agents. But in this case, we don't want to use the seed adaptation. So because our seed clips are already working fine with our 3D model here. So basically, this is how you can set up your I field. So basically, if I change the state machine set to 1, sorry, wrong agent group, it was this one, set to 1. We see that the intersection of the, when we basically try to find the pelvis height and the feet height, the intersection with the ground is going to be at the same level. So for the pelvis will be down here, and for the feet will be around here. So the y of that of those intersections will be at the same level, and so that's why we don't see if we animate the agent. So let's say we set a keyframe there, and then also one at 0. Then basically we don't see the pop that we saw earlier during the seed adaptation video. Okay, that's great. Then let me show again that seed section just to show you seed section, just to show you again the animation. Looks fine. Of course, you can always go from stand to seed, so maybe we can do that just to show you quickly. Maybe we can open this guy and select these agents here. Actually, do a bit random like these ones, let's say. You can say they start at 0. We set a keyframe here. We go maybe at this frame and we set 0 again. Next frame we set equivalent to 1. So they will go from the opposite, they will just actually sit. And so you see, basically, you can do both ways. And if you want, of course, either by using the same workflow that I showed you earlier, so you select randomly agents and then you provide a range of states that you want to provide. For instance, it could be 2 and 5. Then you can randomize your sim, and the overrides actually are going to take over, and these agents won't actually use anymore the state that is provided here. One last thing before we finish up with this video. So as you can see here, I've already populated all the sections of my stadium. I've just used group copy modules on all the new agent groups. As you can see, some of them have a follow target, so that the agents actually look towards the center of the stadiums, even these ones here. But as you can see here, the distribution of the agents is quite uniform, and this is because, of course, the meshes that we have used, they have the faces that are basically uniformly spaced. So, when you use some layouts like the grid layout, you have like options for, providing a random space for the agents so that they don't look like they're in a grid. But in this case, because the group copy module doesn't provide that kind of control, especially because you just provide an input mesh, then what we can do is we can provide on top, we can set on top something, a change basically on top of the layout of the group copy. So for instance, we could use an offset module, and the offset module lets you basically provide an offset for the agent. These actually just apply at the first frame, so at the layout stage. You can't really animate these values here. So you could use this field, the position field, which is also used by the layout tool. Whenever you edit anything with the layout tool actually adds an offset module. This happens for all the layouts except the points layout. So for instance, you could say, so I've selected those ones, and I'm gonna click that button so I can provide a range. So I can say 0, 0, and 50. Here maybe minus 50. And in this way, basically, let me select all the agents, randomize, and now they're randomized. In this way, basically, you're baking a value per agent. So this is this agent is actually valid for the first agent. So maybe you can go in here and say, I want this one to be maybe 40. So you have more control. But also, if you want to have a quick randomness, you can just use the random position here. So let me clear the selection. This basically works on top of the position, so you could combine these two if you want. So for instance, here I can say I want 30. So it's gonna offset the position between using minus 30 and 30 as the two values, are the two limit for the range. And so basically in this way, we have done the same thing, but this is not baked. So you can even, very quickly change the value. And again, this is gonna happen on top. So for instance, if I'm gonna select this agent here and gonna say, let me select actually that one, and we say, I want this one to have an offset of 20. You see, this is actually happening on top of the random position that we had here. Okay, so this is the offset module. The problem with the offset module is that it works in word space, so it's gonna offset your agent using the word axis. In case where you basically have agent groups agents that are not aligned with the global axis, like in this case, or if you had a curved section, if you use the offset module, let me just show you quickly. So I'm gonna add the offset module, and I say, I want an offset of maybe 50, like this. You see, they actually moved along the word z axis, so they are actually not anymore on the mesh of the seat mesh. So I'm gonna delete that one. I'm gonna delete the offset module. What you can use basically is gonna be it is the local offset module. So this one actually offsets the agents along their local axis. So the local axes are evaluated in this way. So the z-axis is actually the direction, so the direction in which they are pointing to. So it's basically this vector here. So the vector that is pointing from the agent toward the center of the stadium. Or that locator that we use with the follow target anyway. And then here the y-axis is actually the up vector, and then the x-axis is the vector that is perpendicular to these two. Okay, so here, for instance, if I say you want to use the x-axis in this case because you want to offset them along this line basically, you can say 20, and you see that they got offsetted all of them along their x-axis. So let me set it back to 0. Of course, you can again use the override dialog and randomize the values, but if you want just to have a quick result, you can just type something here, say 30, and now they are a bit like randomized. So even these two sections actually don't look at as uniform as the others. So anyway, this is a quick way in which you can randomize the position of your agents when you use the group copy module. Of course, you can also use this local offset and module and the offset module with other modules if you want, as those actually apply their changes just on top of what you had previously in the stack. Okay, so this is the end of this video. I hope it was useful, and see you in the next video.